The fact is that quantum computing is progressing fast, but it is still about science, in my opinion, not yet about engineering. Please do not forget that probably the key little disruptions which are still needed will come from public sector. The unknown is waiting for you patiently since till you arrive there, and you try to do the thing with 5 nines, and then you will discover zillions of things. I want to learn it. I want to investigate, to explore it. I don't want to have bias or prejudices. I want to go there with very light luggage. Okay, I want to be open to these discussions. I do think that we need more philosophy in science, more humanist understanding of science. I'm a little bit scared of all these people that only think that they will get rich, which is a low understanding of life. Huh?
Welcome to another episode of the Quantum Economy Podcast. Today I talk with José Ignacio Latorre. He is the director of the Center of Quantum Technologies in Singapore. His career spans particle physics, quantum computing, and ethics in AI. He holds a PhD from the University of Barcelona and completed postdoctoral work at MIT and the Niels Bohr Institute. He has written more than 130 papers and several books on science and philosophy. He has advised governments across Europe and the US, and he's now helping Singapore shape the strategy for their quantum technology agenda. In our conversation, we look at the role of governments and industry and the ethics of superintelligence, and also the idea of a shared quantum future, one where knowledge is open, global, and human-centered. Here is the Quantum Economy Podcast and my conversation with José Ignacio Latorre. You're in Singapore, right now, and I've been looking a lot into that academic development in various regions. I'm looking at what's going on in Europe. I know you have a very good overview of all the fields, but particularly in Spain, Barcelona. But tell me a little bit about what we're working on in Singapore at the moment.
Well, I'm directing the Center for Quantum Technologies, which is a very large center. We are around 300 people. We do have around 100 research lines, so it's not a small action. But maybe I should tell you that the main difference between Singapore and other countries that I know the plan quantique in France, I know the things happening in Germany, I know the actions in Netherlands, in Finland, in the US. When we made the plan, the quantic, the actions for the quantum world in Singapore, before we travel around the world in delegations. So the National Quantum Office, I'm part of that. We went to the US several times. We went to Germany, we went to France, we went to Netherlands. So we try to make a plan here, which is very coherent, well-funded, articulated, with a clear distinction between what is basic science, what is translational science, what are the capability building actions that we needed. So it is much more design, okay, from scratch, than rather than taking the players that you already have and adding funding to each one, like it is happening in some countries. So in this sense, our actions here are much more focused to produce a quantum economy.
That's good. No, because I want to talk to you a little bit about the the progress lately, also with the big players and the various aspects and the commercialization of quantum. But I was just curious about how you see the relationship between academia and now in the corporate world, and do you have a feeling, because what I've been observing is that a lot of the great physicists are now quote unquote taken out of the academia ivory towers and put into the corporate labs, and they're equipped with almost infinite access to money. But how do you see the development in general now in academia? Are we keeping up? Do we need to change something from a structural standpoint, or how do you see this?
Definitely. So let me bring you my honest, as usual. I'm everybody knowing me knows that I am transparent. Okay, so the fact is that quantum computing is progressing fast, but it is still about science, in my opinion, not yet about engineering. So it is not that everything is solved and now we simply have to tune the engineering. I do think that all the technologies which are being pursued have bottlenecks that may be uh, dramatic in some sense, okay? Because not all these technologies will survive in the long term.
Mm.
So we need research, basic research, applied, but also basic research. I don't see the future of superconducting currents going ahead unless there is some basic improvements. Okay, I do believe in that. I think the same for ions. I think the same for neutral atoms. Each one I could tell you, each one, what are the bottlenecks that everybody knows.
Feel
But
free
we,
to get into that and just elaborate a
yeah.
little bit. What do you see as promising, promising approaches that are more promising than the others, and also the bottlenecks? I would be very curious to hear your take on the various bottlenecks on the approaches.
Uh, okay, but just to finish your first question, which I think is absolutely relevant, absolutely relevant. What is the relation between uh, academia and industry? Well, in my opinion, we have to collaborate. Okay, we have to, with different point of views. Our point of view is the basic science. I'm in the public sector, but I'm super happy to collaborate with industry. Okay, and we need to work together. Now, to give you an example, it turns out that we are discussing how to engage with different companies in Singapore. We have a lot of them that want to come, and some of them are already coming. So we did an exercise, which is we checked the publications that have been done by the different famous corporations. Well, just CQT, which is one of the centers, we have published more than all of them together. Okay. Uh, why? Because, come on, we have here 300 people. Okay, it's a lot. It is a true fact that the industry does not publish everything. Okay, a piece of them are kept, but there are companies that publish quite a lot. But we are one institution. How many universities you have in Germany? How many universities you have in Europe? How many in the US? Are they good or bad? Do you think that Oxford is bad? That Yale is not good? That MIT is not a fantastic university? So when you put together the amount of work done in the public sector is manifold, the one in the corporations. But it is a true fact that corporations have a PR, which is fantastic. So the fact that they appear more often in the news does not mean that the necessary progress that we need and is being made is substantially supported by the universities and the public sector. This is sometimes forgotten. Okay, this is sometimes forgotten. Same for software. So the recent things that happen in questioning factorization or questioning post-quantum crypto. Well, one happened in Xinhua in China, the other happened in a university in Israel. So as you check the relevant papers of the last year, they happen in the universities. So don't take me as a negative guy for industry. Not at all. I'm all in favor. But please do not forget that probably the key uh, little disruptions which are still needed will come from public sector. Does it make sense? My answer to you?
Yes, I'm very happy to hear that because you always have that tension to say that, the corporate doesn't have to follow the strict publication and get the credibilities and the peer reviews and the approvals. They're looking at practical implication, right? So I'm very happy to hear that. And you have that day-to-day operations with the CQT, and you have that like academia whole-fledged view of what's going on. So that was a very good answer to my question. And therefore I would just like, also from that standpoint, we could translate into the second part that we got into on the various approaches. Where do you see the bottlenecks, and also like which of these approaches to build? And let's stay with the hardware, with the compute for now, and just say for the computation. Right?
Let me give to you a question. Let's change the role here.
All right.
So I don't know how old are you, but did you ever see the old TVs, the big, the bulky TVs that they would sending electrons to your eye? Okay, they would heat the screen and send a piece of light, but you were, irradiated with electrons. Okay, and now you look at your TV. Okay, you don't have that. You don't have electrons. You have LEDs. You have
I don't
different.
even have a TV. I don't even have a TV, right? I used to,
Okay,
and I used
you're
to know.
right.
I used to have those one, like my dad was in telco also.
Yeah.
I was very interested in his old devices, so I like to play with that. So, but yeah, so please continue.
Okay. And
I'm not.
then what about the phones?
Yes.
Remember, there was a phone with a cable and electrons were coming. So
Yes.
it turns out that our technology has gone from the time where we did all these processes with electrons, and now we do them with photons.
Yes.
Okay? There are, in some stages, you still have some electrons in your phone going around, but the communication has moved from electrons to photons. Why? Because they do not interact. They are much well. They have every possible advantage. So it is a fact that we are moving our technologies to a lightweight, to the minimal element that you need from physics to do what you want to do. So we are still nowadays in classical computer, and I'm talking about GPUs and the famous AI, we are still in the primitive stage of using electrons, which is unbelievable that in the 21st century, humans are still debating how we should be computing. So I am absolutely convinced, okay, that we will move away, obviously, from classical computing. If nothing else, because we will save energy, okay? Just using classical logic, we should not be using electrons as they are in this primitive way. Now, there are three options. You go down to low temperatures and electrons will behave in a superconducting way. That's a possibility. Or else we take a more dramatic step and we substitute the basic element to encode information and manipulate it. So we have a very first solution. Nature gives us candidates, which are atoms. And they are all identical. They are given by nature. They behave perfectly fine. This is such an appealing concept. Go down to atomic computing, okay? Computing with atoms. But then there is still the crazy idea that no, why don't we move to photons like we have been doing for everything? But now you understand, and this is the first bottleneck I want to mention, that photons, which would be fantastic, do not interact. If people know quantum electrodynamics, they know that the photons have to interchange an electron, and therefore the Feynman diagram is photon photon, a box of electrons, photon photon. This is suppressed by a factor of the alpha of pi to the 4 power, and on top there are terms in the energy, so it's negligible. So that is a big disadvantage. It's an advantage because we protect coherence, and they are long-lived, but man, is it difficult to make them interact a lot. So we resort to this idea of post-selection. Post-selection is probabilistic. Then you do have to fight a new battle that we never thought of fighting, which is that nature decides when things happen. And if probabilities enter the game, you have to beat exponential decays. Because if you only have probability 0.9, that two things happen is 0.81, three things happen, and it goes exponentially fast to zero. So a new realm of difficulties and solutions enter there. How far are we? Everybody knows that there are a number of companies which are doing well. I don't know. Are we mentioning companies here or not?
Yes, please. Yeah, no, we should do that because I want to also get into the economical implications. So please get into the
Yeah.
companies.
So we have
Both, yeah, you can go get into both the large big tech players and their various approaches, as well as startups and promising approaches in various fields. So please do that. Yes.
well, I don't want to bother everybody, but there are the big players like PsyQuantum, but you have Anquandela, but you have Orca, you have Xanadu, you have others that have all my respect. Okay, each one is trying to do something different. You may work with individual photons, discrete variables. You may go into continuous variables. Again, each one has different problems. You may go for probabilistic creation of photons. You may go for deterministic creation of photons and therefore interfacing with matter. So there is a universe of research, okay, and on of engineering also. Fantastic. Let's go there. I don't know. I'm sure that they will succeed in some time. I don't know how far away. On the other hand, we have the solution that as of today works the best as of today. And for that, I could claim an analysis done by Jülich, the Center for Supercomputing. They have all sort of computers. They have performed a check, and the ions are performing better than the others as of today.
Mm-hmm.
But man, again, scaling, how do you scale? How do you scale ions? It is not at all trivial. And beyond one trap, it's pure research. So
Mm-hmm.
again, I insist, it's not engineering, it's
Right.
research.
It's a good point.
Uh,
Yeah.
you see, in every one of them, I can tell you there is a research
Mm-hmm.
element. And then you go to the newcomer in the sense that they have progressed very fast, which are the neutral atoms. Wow, this is really good because you have a gas of neutral atoms and that scales. Right? You can inject as many as you want and you have tweezers and you move them around. But are they long lived? Okay, you play with the levels and you play, for instance, with the Rydberg interactions. No, so only when you want them to interact, you modify them, okay, and then they see each other. But at that moment, they see everything. They open the box and they see everything. You have to do that very fast, strong coupling. Again, how do we do that? It's an unbelievable, difficult task. These, may I say, all of them have uh, proofs of concept. So it is not that we have a doubt that this is possible. All of them have passed the level of proof of concept. What is not obvious is that to reach the level of error correction to go ahead for scaling, you need precisions in every piece, which are between 10 to the minus 4 and 10 to the minus 5 in the fidelities. So maximum error is 10 to the minus 4, 10 to the minus 5. So that extra decimal point is amazing. I was talking to one of the engineers of one of the large corporations, and he told me after 3 nines, after 99.9, every 0.1 is you are discovering things that you never imagined they were there in your system. Noises, effects. Well, that's research. I was telling this engineer, you may know that when CERN was doing the analysis of polarizations at LEP, the electrons should be polarized, but they were not quite polarized, and they were looking at the defects of the noise, and they noticed this thing that twice a day it went up and down, up and down. So they realized that they discovered the moon, because the moon, by gravitational interaction, changes the surface. So the Earth acts as a liquid, so it's a tide, and the Earth in Geneva raises 30 centimeters because of the moon, and the ring changes, and all the perfection of the ring goes away. So when you go to high precision, you discover the moon. And then they subtracted the moon, and there was this night. One day there was no noise. What happened? They discovered the only strike in the train system in Geneva. No, and then when they counted that, they realized that they could see how the Lac Léman had more or less water because the pressure into the thing. So that is precision. The unknown is waiting for you patiently since you till you arrive there, and you try to do the thing with five nines, and then you will discover zillions of things. So this is why all these technologies are waiting for a solution. And the one that I should mention is superconducting qubits. That again, I think they should be explored in depth. Uh, you can print secret fantastic. This is now you all the semiconductor industry is there lurking to see if we find the right way. But again, you need these many nines. But as soon as a qubit is fixed, then you have information has to be swapped. You have overheads of operations. You have noise from everybody around. Have to shield the things in unbelievable ways. You have to manage to get them to this very high precision in a sustained way and without fluctuations. As of today, this is not so. Let me insist that we know when I said that as of today it is science, it may change tomorrow, but it's a fact that what you have to test is not the gates, individual gates, but secrets, solution to a problem. And then is what you see all these effects which are combined, okay, which is the very heavy test. And there are many other qubits. Let's not discuss more of that. No?
No. I mean, it's someone that always when I ask about intuitions and feelings from scientists, that's that like I can only do what I understand, and the foundational physics are given to that extent that what we know today. But still, if you look at the progress now, so you mentioned that the corporates have a lot of PR budget, and I think you almost I think we talked a little bit about this also, the outlooks in the past when we met, and you talk about the quantum, like the quantum winter, and basically the overhype. Um, don't you think that if you look at history, it seems that when we, from a scientific perspective, look at challenges, that all of a sudden we tap into some new approaches that helps us like overcome things that you talked about that we couldn't imagine. So don't you think that this outlook for progress is much more promising given the fact that many more people are working on it? We are getting more resources. So my question is more of that, like, don't you think there is some underlying um, force in nature that helps us discover the unknown to a broader extent if we focus on it? So aren't you more optimistic about the progress?
I am super optimistic. Yeah, yeah, yeah. You are right. I mean, if the man can clone Dolly, it clones Dolly. If you can go to the moon, you go to the moon. If you can modify the DNA, somebody will do it. So the very fact is that we know by now that we can do quantum computing. So be sure we will do it. Okay, it's inexorable. It's the effort is relentless. It's unrelenting, inexorable. I don't know which is the right word to tell you. There is no way this will be stopped. Okay. Now, you may know that I work a lot in artificial intelligence since the 90s myself. Uh, and I follow very closely. Well, I was doing artificial intelligence for, at that point, for high energy physics, not for CERN. And there were all the winters and the springs and another winter, another spring. I remember distinctly discussions about the impossibility of having an automatic translation. All the money the European Union was putting into that, because there are so many countries, it was a mess. The European Union wanted to have automatic translation. It was a failure after a failure after a failure. And many people would say, no, this would never. This was an effort to mimic the human brain, and the human brain is so much more complicated that this is undoable. But then in 2000, we had deep learning, we had deep neural networks, then we learned convolutional neural networks, and little by little, better machines, more computational power, and then the transforming architecture, and then suddenly we are surpassed by artificial intelligence. So why don't we think back? and talk to the people that said winters and we will all never achieve. Where are they? Because I was fighting at that time in favor of science. Said, look, there is nothing special in our brain but complexity. Let's find the relevant uh, degrees of freedom. Let's understand the basics of processing. And as soon as we understand that, we will have artificial intelligence. And I tell you, this is exactly what happened. Exactly. And the brain started, Crick had the book about the how the vision works and how the pre-processing in the vertical chain. We learn from science, basic science. We started to understand the pre-processing of information till it goes to a deeper layer and so on, and we started to mimic that. And then it happens. Now we understood attention is what matters. We need long distance correlations. We have included them and started, for some people, miracles are occurring. Well, to me, is that we have to go at the speed of science, not at the speed of business. It's not that a guy in Brussels says we need automatic translation, give it to me next year. This is not how science goes. Not this way. Science requires to understand the problem in depth. You have to go, you have to be your own enemy when you publish. If science is driven by publications, by having 20 citations, you don't get good science. As soon as you give good brains freedom and they are ambitious, man, they come up with progress. We are at this stage, and there is no doubt that as we are talking, Anders, there are plenty of people in the labs who are doing fantastic things, and it will show up, will happen.
Yeah. No, this is also man. It's also hard for me not being a physicist and to argue, but I just look at history as to go back in order to have an exponential progress, and there will be breakthroughs in science. We will extend the periodic table. We will find out some material design that we couldn't imagine. So this to me is inevitable. With compute, the powers, even with like GPUs and energy efficiency. We don't even need QPUs to have that type of progress. And imagine if we could have like that extensional layer to it. And therefore, I'm also on your side to say that it's inevitable that it will happen. It will happen, right? It's just question
It's
of
I think that the ChatGPT and all these things, just the first steps. So our brain uses nothing. No, it uses what 30 watts. I mean, and we are now mimicking all our efforts with, we need a nuclear plant to.
I know it's
This
great.
is don't. It's a mistake to think this is what will happen in the future. We
Mm.
will we will go beyond LLMs. We will go beyond what we have learned. We have learned this is a step.
Yeah.
No, everything's links in the chain. That literally. So we have discovered a fantastic link, but now we are working on the next link. Okay, and you will see things will improve in artificial intelligence, and definitely the big jump is understanding quantum in depth.
Mm-hmm. Yeah, but I mean, we're kind of sort of getting bored of LLMs, right? We know the challenges, and we're looking at world model, foundational, different approaches, as you said, to the foundational models, and these things happen. But you also said something that I resonate with, that we need like a better understanding of the problem. So I remember like reading David Deutsch and thinking about the infinite potential for progress. Yet at the same time, when we say I have a better understanding of the problem, given the nature of quantum physics and our understanding of the foundational reality, we are still building on top of an initial assumption. So I always say if we play with knowledge, you have to know your assumptions, right? So what does that mean to me? To me, that means that we are building something where we understand the problem better, but not at the first principle, at the foundational level. And what I see here, and I know you've written quite a bit about it, are implications of this progress. So one field is obviously the ethical implications of quantum computing or super intelligence. And I would just like to have your take on this right now as you see the rapid development where we are. Where do you see the ethical challenges, and also how do we cope with these?
Yeah, well, because I told you that I was working since the 90s, I got more and more concerned with the use of AI, primitive as it was,
Yeah.
okay? But you could immediately see that it was used for the bad, you know? And I was very concerned. Actually, I wrote a book, as you said, on ethics for machines, where I try to spell that for me, society has to confront two main problems. One is the relation between humans and machines, the real relation, the ethical relation. And the second is the aging. Okay,
Mm.
I think it's a huge problem that is coming. Okay,
Yep.
how we will live in a society where everybody is old. Uh, so these two challenges are enormous, in my opinion. They are enormous because both require a consensus uh, to make the laws limit a number of things, and we are not very good at consensus, as we all know. In particular, when many countries are involved, then the consensus becomes almost impossible. It turns into war uh, systematically.
Mm.
So, how are we dealing with this exponential progress uh, that is taking place, and absolutely zero understanding on the side of individuals at large? Okay, uh, this will be at some point maybe bad. Okay, so actually I just happened that the government in my country appoint me to a position of let me say advisor. Okay, a team of 17 people who are advising, and I managed. Finally, I talked a lot to people that knew law. Okay, and I learn a lot. And I see the difficulty in establishing laws because you have a corpus of law, which is before you. And you have to adapt and be consistent. So this is quite a challenge. And our recommendations were poor man's recommendations. So the idea that we should at least take care of anything related to AI that affects a lot of people.
Mm.
So not if you make a business and you want to sell more shoes, that's fine. Use it, use it. Don't stop the economy because you restrict the use of AI. But if you're talking about education of kids, man, there you have the terrible things about bias, about populism. You have to be very, very careful.
Mm.
And the same for the systematic cheating on the old people that they don't understand technology and they are overwhelmed and they are discarded from society. So again, the uses of AI that do not take into account that they are old people that don't understand,
Mm.
uh, it's it's not human in my opinion. It's not understanding what humans are.
Mm.
So these are elements which to me are relevant and have to be discussed. But quantum, which is our subject, uh, I do believe that a world with quantum computers in every country is better than a world where quantum computers are owned by a few superpowers. I
Mm.
do believe in that. I don't see a future which is reasonable if all of Africa, half of South America, if all of very many countries is left out. I think it's bad.
Mm.
I honestly think it is bad. And we should really try to defend the idea that humanity is achieving a major step, which is understanding using quantum, understanding and using artificial intelligence. And this should be an endeavor for humanity, not for a company, in my opinion. Okay. So as much as I can, I will I will collaborate with companies, but I think that the knowledge should be human. You may remember that the sequences of DNA posed the first problem of this kind, no? Whether it would be a property of a company, and then you should be paying for knowing about your DNA, or should be a public knowledge, and finally turn out to be public. Okay, so now we are again approaching this level of discussion. Is it the control of atoms, the ultimate scale to manipulate information? Is it for humanity or for business? I hope it is for humanity.
That's a very powerful statement. I like that. That's a very powerful statement, the control of atoms, because this is, I mean, so I was thinking about this because you have been also a big driver of getting the UNESCO UN Year of Quantum Science and Technology. And as we both know, Ghana was one of the countries that was striving to put it on the agenda. And I was talking to them about like, how could we then quote unquote onboard the global south, or make sure that the corporate incentive is not so high and the drive of corporates is so much bigger? How can we from a scientific, or how can you from a scientific academic standpoint make sure that that happen? I mean, I think this is a huge challenge. I totally agree. I mean, Europe in particular, but other Western regions, we're getting older. We're going to get old. We get 1.3 trillion. The whole population structure is clear. On the other hand, we have in Africa 1.5 billion, which will grow to 4 billion. So we have the opposite, like with all the young people. But how can we enable these young people to become quantum literate, to have quantum literacy, and to facilitate for building quantum computers or structures to be a part of this? Do you have any like concrete, specific ideas to
Yeah,
this?
I have two, I have two actions being cooked. Two actions. I think it's not fair that I say something, but believe me that there are possible actions, and I'm working on them. And the basic principle is generosity. Okay, that's a basic principle. Accepting two facts: that knowledge is born everywhere. So
Mhm.
it's not that people are stupid. They're as clever as you are. It's a matter of opportunities. Okay, and that the balance is restored using the basic idea of generosity. If you understand this fact that there are intelligent people there, and on top you can be generous, there is plenty of ways of organizing the things in such a way that something will happen. Hopefully, okay, in not too long, you will hear of some action.
I like very much how you put this into those simple words, just combining the very foundational understanding of how progress happened. I mean, I've been writing about this, about like we weren't those geniuses with the Industrial Revolution that were so much more capable or innovative. We just happened to have the resources and be at the right place at the right time. Talking about like the rivers in England, that was much easier to tame than the Himalayas, coming down with the mountains into the Chinese region or the Asian region. So it was much easier to put up a, a structure for the cotton industry on the English River, and also coming from the fact that a lot of the resources had been plundered out of South America. So you had capital or resources, and you had the timing of the technology. So I totally agree with you, and history shows that over and over again. We are capable to process knowledge and have good ideas. And the concept of generosity, that's so simple, but it's also so powerful. So the understanding of collective drive for humanity, I am because you are, right? The essence of, and I've used this in the past, the whole American dream was about the individual and the Declaration of Independence. And we need kind of sort of that commitment to a declaration of interdependence. And that is very much about like caring for others. And I like how you simplify this into very clear words that resonates very much with me. So I'm very thankful
Uh,
for that. Yeah.
I have to tell you that one example of something that happened here in Singapore that I appreciated is that in a dinner I was with one of the guys who was responsible for the policies for COVID. COVID was a big thing. Singapore, being such a well organized country, could address the issue in a, let me say, top down way with with very wise things. But you know what? It was impossible to stop it because if you do well, but your neighbors are not well off, you are not well off. And this guy in the dinner was telling me, we learned that not only we have to be good, we need that the countries around us are have a good life. You eliminate the immigration pressure, you eliminate the dangers of viruses going around. So generosity is the element which is needed for all our neighbors all around are good. So that would eliminate immediately all this pressure of immigration that many countries have. Why there is everybody knocking on that door? Because in at their homes it's a mess. So we have to work hard on making them happy at home. And in science is that science should be developed in all countries. Yeah, let me give you another example, Anders. How much does it cost to have a lab? You know, I was in Abu Dhabi, okay, so I know because I started with a desk. How much does it cost to have a lab? Well, you have to do the facility, you have to, it's superconducting currents, you have to have 3, 4 fridges, it's $1 million each. You have some fast electronics, okay, you add a few millions, uh, and then you have to hire decent people, and you have some salaries. Well, it is clear that it is less than 100 million. Okay, tell me one country that does not have 100 million. Every country on earth has 100 million. So it is not that they don't have the money; it's that the governance of the money is not educated and don't understand that we live in a society of knowledge. Okay, so it is essential to try to get good governance in every country. So that's why democracy is such a relevant point when you talk about the progress of science, is how we orchestrate all these needed good governance with the complexity of the political parties and so on. But I have no doubt that we can make small temples of quantum in many countries. It's not impossible, absolutely not. Many people have told me, no, but you need talent. Oh, you give a good salary, people come. You can build the labs. Yes, you can build the labs. So what is it? It is just that everything works according to the right well-doing, relating to the governance. We have to have very good politicians on top. That's a difficult part. If you tell me about South America, this is the most difficult piece. Africa, it's changing every day. So Africa is a mystery how it will evolve.
Yeah, I agree. But isn't it also so that a lot of the challenges that we also have in enlightened democratic countries today, it's become very binary because it's very much down to the optimization society where we just strive towards very finite ways of answering right and wrong, zeros and ones, speed it up, and we become very reactive. And as we now have abundancy of knowledge and an infinite, almost free access to knowledge, and I strongly believe, and you mentioned that also on the energy sector, that within the next 10 to 15 years, we might even move towards the marginal cost of energy plunging towards zero. Isn't it so that we then need to have some kind of incentive for behavioral change? Meaning, it's not about knowledge or access to knowledge, it's about a deeper understanding of the problem, and maybe most of all, a deeper understanding of the potentialities being the incentives to invest and to change. I think this is also a very big part of the how children are raised in a knowledge society where we have educated experts and not thinkers. We have maximized the art of being right and neglected the philosophical mind, namely the art of being wrong, the strive towards progress, the will to truth, if you like. And I think there is a very big challenge for academia, in particular also in kindergarten and in education, to switch from that we have access to knowledge, now it's all about understanding. I don't know how you see that.
Yeah, I think we all agree on what you say. I think many people are concerned, no? But just to add my way of saying things, I think there is a misunderstanding. We do not live in a society of knowledge.
Mhm.
We live in a society of information. Information is accessible. You can check in internet everything. Knowledge, no. So imagine you have to go through some heart surgery,
Mhm.
and the guy says, "No, I watched 20 videos. Everything is in internet." Well, if I could have a doctor that has been trained for many years and has gone through the operation theater with the professor and has been learning, knowledge goes at the speed of human comprehension, which
Mhm.
is slow. Information, you can discard every 5 seconds a web page that contains all the information. So, no, it is not true that because there is information available, you acquire any knowledge.
I
This
agree.
is a big and profound mistake. That's why, in my opinion, this fight has to be started in the school
Mhm.
system. It is not about the quantity of things they see or how recent and useful are. It's to dip into one thing and understand it. I do believe that it is fantastic to go back to reading books, and enjoy whatever novel that, as a young man, I enjoy. And I think this is a basic change.
Mhm.
Uh, the fact that this is not even understood at the level of politics is what is preoccupiing to me.
Mhm.
Okay, uh, I can tell you that as a director of thesis, no, when I've directed many theses, to me, I need to be on the blackboard with a young guy
Mhm.
and discuss and see and read his brain, see how he thinks, see him developing a little discussion with me on how to do things. I never look for accumulative information he may have
Right.
read. It's a completely different thing. Will he be able to penetrate the problem? And you need to be equipped with an intellectual instruments, of course. And one of them is information, definitely. But this idea that a good brain is a machine for learning, is a machine that is able to explore and acquire whatever is necessary to go ahead, this is the essential point.
Mm.
I'm a very romantic guy, Anders.
No, I'm also very romantic towards the human species, but I think also I think we're saying the same. We just use a little bit different terms. So when I talk about the fatal information society, we had a lot of information, and then we put compute on it with AI, and it's getting better by the hour. So coming back to your doctor surgery, what today in a single doctor who has been trained on experience and has learned in school to save data and then to apply that to patients over the years, he cannot compete with a surgery or a doctor with AI and the machinery and the automation. So the precision, also if you're going to remove a cancer, you would never rely on human precision, right? You would always have the expert knowledge of a machine. So what I was referring to is that in this society, what I observe is that we as a human beings, and we both romanticize and on the very essence of being, we become very reactive. So we react to impulses, and therefore we become a state of, I call it undead. It's a kind of new existentialism where we have the philosophical zombies wandering around, and then we are not perceiving, we are not quote unquote learning. So, what I was referring to with the educational model is that we have been taught what was right and wrong, and we have not been taught how to learn. So the essence to learn how to learn, if you have infinite access to, let's not call it knowledge, call it sorted out information that gets better every day, then the skill that you need is the actual skill of learning. Coming back to your thesis discussion where you dance and you understand, and there are two people coming at it that could together develop something that could move into the unknown, or to get a foundational understanding of the problem and then improve this problem. So we don't create finite solutions, right or wrong, we create better problems. And that skill, that is about the arts, the scientists, the romanticizing about, the various things. So I think we're saying the same, that it's kind of sort of a more of an era of generalist, where we see the pattern and the complexities, and we can tap into expert knowledge and have a world model, foundational model to enhance our capabilities. So this is what when I talk about understanding, of reasoning, of the German word Vernunft, or that's what I say. The society of understanding is what must emerge after the expert educational model that we used to tap
We all agree on. I think we are absolutely on the same page. I was asked recently to know a student what are the questions you ask. I'm honest. I said, new guy. I say, you have $2,000. Which country would you visit? As a first question. I'm not asking about the electrodynamics or photons.
in.
I'm asking because then I know whether he's a conservative mind in the sense that he does not want to explore things. Okay, he prefers his comfort zone rather than being in stress of being in a place where you don't know things. I can learn how much he has read indirectly. I know what is his culture, and it's surprising how often people don't want to move from their little corner, okay? And they are already at 20 something, they don't want to move. I said, well, man, we will not understand each other. Yeah, yeah.
But it's interesting though, and I want to get back. I like that romanticizing about, life for human beings, the mensch, and I love the word mensch, right, from the Yiddish, the active, positive thinking. Also, you're writing, there is a sense of like the philosophical pondering of the wonders of life, right? So let me ask you this: what do you think, or what's your hinge on this? So you talked about the brain being something to be understood because it must be a part of our to understand, or to explore physics, the foundation of physics. Do you think it's all something that we will eventually understand? Is the brain just a part of like that known physics, or is there something beyond? I'm referring to our conscious experience, the qualia, the mind, whatever you want to call it.
No, I think consciousness is a emerging phenomena. We have this word emerging.
Yeah.
When we have things which are called these are toy models for what we are discussing, but it's a fact that the parts of the laws of the parts do not bring a hint of what would be the what will happen in the long term. So the fact that two little magnets may attract or repulse each other, it is not, you don't see that there will be a phase transition and the full thing will become a ferromagnet. Something from the small laws, you don't really see this emerging. It's an emergence of phenomena. This is complexity. Okay, and this is a big dispute between the physicists that go to elementary particles versus the condensed matter, that in the parts you don't see the magic properties that you want to describe. No? But it's a fact. From very basic laws, you develop the many body system develop behaviors that are complex. Okay, that change of complexity has no limit. I mean, so I don't believe that the brain is uh, anything else but a very complex machine, extremely complex, and that emerging phenomena happen over there, and consciousness is one of them. Okay, it's simply uh, the fact that the machine is describing, is understanding itself, and otherwise you have to convince me very heavily that there is something magic in our brain. I had one of very best meetings in my life was a thing that I'm not particularly religious. I must confess that, but I'm super respectful. Okay, I don't think anybody has a solution to anything or any answer. But I was invited to a place where there were only 10 people to discuss the main things. And it was really good. By the way, I learned that there are very many very Christian scientists which are famous because they were there. Uh, and there was a biologist, no? And he was saying, he was in his little pitch, he was saying, I'm Christian. I would love to believe that there is something. But every time I do an experiment, in every single experiment I do, I only see chemistry, unpredictable chemistry. I never, in my research, because he was a guy working at the very basic scale, I never see anything. And he was accepting, no, this idea of that my scientific brain doesn't see anything. Well, I only have a scientific. On the other hand, let me say that I met in another meeting one of the guys who have written the book on religion and science, which is the most famous one for Christians. It is Beyond Science is the title, and we were having breakfast, and I was questioning, but how can you believe these things? He was a particle physicist who dropped everything and he became a priest, okay, at 55. And he said, look, J.I., well, he said Jose Ignacio, look, J.I., it is you who is in fear of asking questions. You are in fear of accepting that you don't know. And, it has been all my life with me, that conversation, that I'm weak brain, I'm a weak mind, whose comfort zone is to argue in the way I was doing, no? That everything is emerging and so on. Anyway, I belong to Descartes, to the 17th century rationalists.
But you romanticize and you're open for that. I'm an agnostic atheist. I'm like, I like what you say. I'm very respectful of any belief because it gives you something to stand on. And many people need that foundation. When you go down the rabbit hole, I wrote. You probably know the book I wrote about the simulation hypothesis. I took on, and we just recently published, Florian Neukert and I, the singularity paradox, where we argue that basically the externalized creation of superintelligence or the path towards singularity or whatever, and an externalized entity is not a good path forward. So we argue that we need to start with the mensch, the human being, and then hack biology and chemistry, and from there enhance and build AI. So we call it artificial human intelligence for that reason, because if we romanticize and we are open, and I'm not with Don Hoffman, who argues that reality emerges out of consciousness, so consciousness is foundational, nor can I tap into that answers of yours saying that, well, the brain is a machine. And I would say, well, JI, is it a quantum computer? What kind of machine is it then, right? And then we dance off into Roger Penrose and Stuart Hameroff.
Yeah.
And we get into all that, challenges of wet, fluffy things. And I'm not going to leave you with it's a machine. Then, okay, if you're convinced it's a machine, then show me, is it classical? Is it compute?
It's a classical.
It's a classical machine. There is no quantum compute going on in there. There is no no understanding of the collapse of.
Quantum, as you know, and this goes back to Schrödinger when he wrote the essay "What's Life?" Okay,
100 years ago, right?
Yeah, 100 years. It's a necessary building block. Is the one that makes that the geometry is exact, and then you have a Lego, and you can play with the Lego, and you can pass information because it's a crystal. No, it's a non-periodic crystal, and that very profound idea is provided by quantum mechanics. Although it is in principle probabilistic and everything, it just happened that, and nobody explains that. But when you do the atoms and you do the orbitals, they are exponentially suppressed when they leave the zone. And this exponential suppression, this is in the differential equations, makes all the angles exact, almost exact. And then suddenly you start to match LIGO. No? So although the wave function, its probability, it turns out that it is exponentially concentrated in different places. That's the magic. Given that, you can codify information, you can pass it to the next generation. Everything can go classically. No, you don't need any further quantum
Mm-hmm.
mechanics. There might be some elements of quantum mechanics, as you know, in the birth compass or in photosynthesis, or they have been proposals for that. But this is marginal. We're not talking about intelligence there.
Right.
So anyway, I'm a romantic, believe me, because I
Yes.
love art. I love theater. I
I
love
know this is.
uh, everything very actively, may I say. This is one of my paintings. No, here you have Dirac talking to Feynman. Okay,
Yes.
in Warsaw. Yeah, yeah,
Oh, really? Wow, that's amazing.
yeah. So I do believe that my life, at least, I don't want to advise anybody, but my life has to have an element of beauty every day. I need it to survive. I need it. I have to equip myself with beauty. Okay, I was reading this weekend an unknown manuscript that appeared recently by the wife of Dali, of Gala. Oh man, what a beautiful passages there were over there. There was intrinsic beauty there. I feel privileged of filling me with beauty, with this appreciation of. I think it makes me better as a scientist. So I'm a romantic, but I'm a rationalist. I think you are the same, Anders.
But how
From what I know from you, I see a lot of commonalities here.
Thank you so. I mean, first of all, thank you so much for making this a wonderful start into the new week. And it was would have been a perfect way to end this. But I think this is why your approach to science is also so important, and also to me as an inspiration, because when I think about this, and we take that aspect of the experience of the beauty, right? It is the conscious, self aware experience of your experience that brings the Lebendigkeit, or the liveliness, to life. And what I see from a computational standpoint is that when we build the brain and we replicate, and you referred to Feynman, right? So if we're going to simulate everything, we will do it quantum with a quantum computer, or applying quantum theory. And to me, the risk here is that when we start to replicate the neurons, and we understand the firing and the connectivity, and we have 10,000, we have 100,000, we have 100 million, and somewhere down that road, there is a path where the light, the vitality gets overwritten. So the conscious experience. So you could say, Anders, I'm a romantic, but I don't know if you're conscious, Jose Ignacio. I have no idea if you have that experience of strawberries, right? So this would be like I always use the reference to Narcissus in Greek mythology. You have that aesthetic, the beauty, and the mirrors in the water, but there is a mirroring, but no perception. So the lights are on, but no one home. And I think this is the risk if we hand over everything to technology and we only strive for progress and we do not have understanding. That's the power that I see with quantum computing and the rapid progress of AI, that I am not, I mean, worried would be the wrong term, because if there is no perception, it doesn't matter, right? So I think this is also why I romanticize about consciousness. I always have that, because you also mentioned it quite a few times, was that I always say that as long as there is one more question to be asked by a conscious being that can experience that this being has learned something out of that answer, so there is chance for progress, referring to Asimov and last questions, right? As long as there is one last question from a conscious entity, we are in a beautiful
I
place.
agree. I agree. But look, let me quote, the father of the encyclopedia,
Mhm.
which is Diderot. Okay. you may know that he introduced many items in the encyclopedia for the first time. But well, there was no encyclopedia before, no? And one of them was automata. Okay, he invented, and he says it's a machine that works by itself, no? And he says in one of his books, he says, I want to know whether the conjunction of an automata and a human is possible. He says, yes or no? And if so, I want to know the consequences. So, look, this was asked centuries ago, and we are at the very same place. So, I'm exactly like that. I want to know what is the future that is ahead of us, and I want to learn it. I want to investigate, to explore it. I don't want to have bias or prejudices. I want to go there with very light luggage. Okay, I want to be open to these discussions. I do think that we need more philosophy in science, more humanist understanding of science. I'm a little bit scared of all these people that only think that they will get rich.
Hmm. Have
Who
you
pursue
looked
a low
into
understanding
yeah.
of life. Huh? I
Have you
mean,
looked into Stephen? Yeah, sure. Have you
hmm?
looked into Stephen Wolfram's work on singular automata and what he's
Yeah.
doing? Yeah.
Mhm.
What do you think of that?
I think he's a very clever guy. You know,
Yeah.
I knew him when he was not known. He came to the university to give a talk on mathematics, and it was, we will have analytical tools? Wow. And with the PC, it never worked. I mean, so I think he's a little bit extreme on reducing everything to automata, no? But I think it's worth, definitely. Yeah, he's maybe a little bit grandiose, his view of everything, but it's one voice that we have to listen. We have to listen to Nick Bostrom. Okay, I think there are a number of thinkers that deserve to be listened carefully. Okay, and we need discussion. We need discussion. As I tell to all the people here, I mean, thinking that our life is only about getting a little bit more money, I think it's very bad.
Hmm.
Very bad. It's so enjoyable making science that it's really missing the point. No?
Ji, this has been wonderful. I thank you for spending so much time with me, and I've learned a lot this morning. Life is a wonderful journey to nowhere. It's the perception, the experience. It's been a beautiful session. As always, when I meet you, I see the big smile, and I try to pick up and pick your brain and learn. And thank you for your view and also for sharing so many insightful thoughts with me this morning.
And please come and visit us here.
I
Okay.
will come. I will come to Singapore. I will come to you guys and ponder and learn and challenge you. I love that, and
Let's
it's
make the first real workshop on philosophy and quantum, a real modern one.
okay. Let's do that. We'll schedule that. Let's get into a date. Find that you. I've taken you up. It's on record. We'll do that. The first real one. First, and you put out that statement.
Yeah, yeah, yeah.
You said the first real one, so that's a challenge. So we'll
The,
go
the first modern one, not modern.
the modern one. The
Okay.
modern, the practical
Yeah.
philosophy, scientific dance at the outskirts of mind and matter. Gloria and I would call it sci-fi, sci-fi with a PHI, science philosophy. It's beautiful. And for my
Yeah.
humble little contribution, haven't studied these fields. I'm just observing all the bright minds and I'm trying to connect the dots. And
Look,
it's a wonderful, wonderful
let,
journey.
let me finish with one quote by Galileo.
Yes.
He said, "I would, I'm, I'm changing the words, okay? But he said, I wanted to learn the center, but I could only try the periphery." He says, yeah, and I think it's
It sums up our
sharp,
conversation. It's spot on.
sharp. Okay.
It's sharp. It was so many sharp statements, Jay. I can't wait to dig into it again. And I will look for dates to come visit. And again, thank you so much for joining me this morning.